Hello, my name is Griff Williams from Dr. Cormier's Physics 271 class. And today we're going to be talking about magnetic induction. Now, magnetic induction is defined as the process by which a substance becomes magnetized by a magnetic field. The induced magnetism is produced by the force of the field radiating by the poles of a magnet. So, this was all started by two gentlemen, one from England, one from the United States, Michael Faraday and Joseph Hemming respectively, all in the 1830s. They discovered this with an experiment where they hooked up a metal coil to a galvanometer, and they discovered that when a magnet was set close to the coil, nothing happened on the galvanometer. So, but when the magnet was moved either towards or away, it registered a change. That was an induced EMF. But when you move the coil, a current is induced, and that is where we get the magnetic induction from both the induced EMF and the induced current. From this, Faraday discovered a law, and it stated the induced EMF of a closed loop equals the negative of the time rate of change of the magnetic flux through the loop, or EMF is equal to. Now for a little example. The example reads: the flexible loop has radius 12 centimeters and is in a magnetic field of magnitude 0.15 T. The loop is grasped at points A and B, and stretched until its area is nearly zero. If it takes 0.2 seconds to close the loop, what is the magnitude of the average induced EMF in it during the time interval? Now, as to the radius is 12 centimeters, the field is 0.15 T, the time is 2 seconds. So from this, from our Faraday's law, we were given this. And as we discussed in class, the difference in the flux can be notated by the magnetic field times the area. And since it's a simple loop, the area is pi r squared, which comes out to 0.0452 meters. When it's put into the rest of the equation, we honestly just doing algebra, we come out to 0.0339 volts, or 33.9 millivolts. And that is the average induced EMF throughout the change from the large area to the zero area, because when it's at the zero area, it becomes zero, so that's the entire change. And I would like to thank you, Dr. Cormier, and I will see you in class on